I'm happy with my score. Wait, so but you still got the answer right. What is this?
Well, I guess this number is not that far off.
18. Wait, so
It is actually Do I have a Wonder Woman one? Let me. Oh. That's not
yeah.
No,
Okay, so 53. I'm trying to find new years. So how can we cook?
well, I read them in my interest. I was like, you say okay.
H2O.
Yeah, I don't know what.
That is a lot of things.
And you got email his accents and they're together.
That is
Out and we pulled out the
insane.
What was the form? It was just asking, I think you make some more number.
Okay, so
Do you want to see more of it?
better chemistry.
Wait, I haven't even know those questions. Yeah. How do you
Wait.
something like
I got it.
10 minutes?
I'm strong.
Wait. She did. Yes. Her girl is and her boyfriend. I asked many of them, he's like, I don't care, no one cares. And then I saw the meeting at NBA with Lucy, and I saw Greta and Jenny. How do you guys feel about this?
Hey, you almost read it. Some you didn't get it. Me. I didn't hear it. I got all this.
I don't think I have something.
Oh, wait, I got the answer. I think I did my put the wrong numbers in there.
Shit. Has to be.
This is when 18.2.
That's right. Polar ratio.
Exactly. 18.2. It's not like I was telling you. 2.9. Yeah, I forgot about one ratio.
Yeah, I just literally found the picture about it today.
Okay, ladies and gentlemen, to do these problems
requires you to do three things, three basic steps. Step number one, convert what you are given into moles. In this case, you are given so many grams of water. It is the reactant. It is where we're beginning. Then you're going to use a molar ratio to get from one substance to another. The molar ratio is shown by the coefficients in front of each substance in the balanced chemical equation. And then finally, you are going to convert to your final unit. Those are the basic steps that you do in all of these problems. Take what you're given, get it into moles, use the ratio to get from one substance to another, and then come out in your final answer. So, this problem gives you 53.6 grams. That's a mass. We're going to use formula mass. The problem asks you to find how many milliliters. By the way, I should have corrected that. It should have been liters. So if you did your answer, I'm actually going to want it in liters, because if it's in milliliters, it becomes a number that's way too huge. Okay? Produced at these conditions, 0.995 atmospheres and a temperature of 19.7. Okay, if you see a pressure and a temperature, what are you thinking? What should you be thinking? PV equals nRT. PV equals nRT. Now, please understand this, ladies and gentlemen. For most of these problems, you are either going to be given, you're either going to be given moles, or you're going to have to end. Sorry, my bad. I'm not going to give you moles. I'm going to give you grams. Or you're going to have to end in grams. To do this, we use formula mass equals 1 mole. Now, formula mass can go on top over 1 mole to get out of moles and into grams, or 1 mole can be on top over formula mass to end in moles. Depending on which way you use this, you will either end in grams or moles. Now, if you can't write a formula mass, man, that's something we did back in Unit 5. Okay? So you got to write a formula. You got to be able to find a formula mass. H2O. 2 hydrogens, 1.01 plus 1 oxygen, 16.0. But again, if you can't write a formula, you can't write a formula mass. So if you need help reviewing formulas, you need to come see me. Here every morning, here almost every day after school, come and see me. Questions? Okay. You may be given a volume of a gas, or you may have to end in the volume of a gas. Now, it is important here we are talking about a gas, because we learned last week you could also be given the volume of a solution. That would be very different. For this, ladies and gentlemen, you are going to use PV equals nRT. Okay? That is what you are going to use. If you are given a volume, you're going to end up solving for moles. To end in the volume, you have to be given moles and solve for volume. Now again, for you to be able to use this, they have to give you a pressure and a temperature. Some of the problems you're working on right now, I may make it at STP. In which case, you don't need PV equals nRT. If we are at STP, 22.4 liters equals 1 mole. But only at STP. And what I will tell you is on a test, on a quiz, from here on out, I will not give you STP. You will have to use PV equals nRT. Questions? Now, finally, ladies and gentlemen, the other thing that I will do is we will have to go from volume and molarity into moles. Okay? And for that, ladies and gentlemen, we take the volume times the molarity. That will equal the number of moles. Okay? So we'll say you're given so many milliliters of this solution that has this molarity. Molarity means the number of moles per liter of solution. That's what it means. Okay? And I will show you problems like that today. However, ladies and gentlemen, if we know the moles and we know the liters, we could end in molarity. And what we would do is take moles divided by liters to get molarity. The point being, we're going to begin in grams, volume of a gas, or molarity. We are going to end in grams, volume of a gas, or molarity. That's the way these problems are going to work. You should have this down. You should have this down. This was entire Unit 5. This was entire Unit 6. This is the only new thing that we've given you in Unit 7. Okay? Now, the problems that I gave you on your quiz last week, go with that one on the bottom. How, if you're given a molarity and a volume, do we get to moles? Well, we multiply them. How do we find the molarity after we're all done? Well, we know the number of moles that we created in our formula. We should be able to figure out a volume. You can put it back in molarity. So that's what these problems are about. Questions? Okay. So let's begin, ladies and gentlemen, with this part here, which is this. Here's your answer to the problem. You don't have to do this. I do it to keep myself organized. Starting with 53.6 grams of this, I want to know how many milliliters. And by the way, I changed that at the last minute. This should be liters because when I did my calculation and I got my answer, there's no reason to put a number like 35 into milliliters to make it 35,900. So I chose to leave it in liters. Sorry, that's my bad. I have to correct that. I gave you a pressure and I gave you a temperature in the problem. We take the grams that were given, we get it into moles. Formula mass on the bottom, moles on the top. Grams and grams cancel out. Questions. We are going from water to oxygen gas. 1 mole of oxygen gas on top, 2 moles of water on the bottom. Why? Because of the 2 in front here and the 1 in front here. This is a ratio of how much of this goes to how much of this. It's a molar ratio, and that is shown by the coefficients that are given in the balanced chemical equation. That puts us into moles of oxygen gas. Now, if I were going to grams, I would have put another step in here with formula mass of oxygen over 1 mole of oxygen. But since I have to use PV equals nRT, I stop and I get this answer. Why? Because now I got to plug it into this formula. And unlike these, which are conversion factors, which I can set up multiples in a row, there's no way for me to put this in here in some sort of a formula. I don't want to do that. Do we understand why I do this separately? Do we have any questions? So now what I've done is I've taken that moles that I've created, and again, I left a bunch of sig figs here. Why? Because the only time I care about sig figs is down here. I put that in for my moles. The R value for ATMs is 0.0821. 19.7 is 292.7 Kelvin. And there was our pressure, 0.995 atmospheres. We're going to get V alone by taking this side divided by 0.995 atmospheres. What I do to one side of an equation, I do to the other. Moles and moles cancel. Kelvin and Kelvin cancel. This ATM ends on the bottom here. ATM and ATM cancel. I am left with one unit, and that is liters. 35.918 liters of oxygen gas. 3 sig figs because 3 sig figs, 3 sig figs, 3 sig figs. 90% of the time, ladies and gentlemen, 95% of the time, your final answer is going to be in 3 sig figs. Questions? Yes, no, maybe so. Okay, let's take a look at your quizzes from last week, ladies and gentlemen. This is IDA, so if the top of your quiz has IDA on it, ladies and gentlemen, these are the answers for you. You started out with 341 grams of KNO3. You convert it into moles using 1 mole over 101.11 grams. That gave me 3.37 moles of KNO3. Now again, if you then took that and divided it by 0.413 liters, that gives us our molarity of about 8.2. This is not in sig figs because my program will not allow it, but this should be like 8.19, 8.20. Michaela. Can I zoom in? I can try, but it's going to take away some of it, but sure. Okay. Questions? Again, I'm sorry, but some of you are forgetting the first step to all of these problems, which is if you have no idea what to do with a number, what should you try to do with it?
Put it to moles.
Put it into moles. You cannot find molarity without knowing the moles. I gave it to you in grams. Use formula mass to get to moles. Take moles divided by the liters. This is finding a molarity. Not using it, this is just finding it. And to find a molarity, you take the moles of the substance divided by the liters of solution that it is in. Now the liters they gave you were milliliters, 413. That's why this is 0.413 liters. Questions? Question number 2. Gave you a volume in milliliters and a molarity and asked you to figure out how many grams of aluminum chlorate there would be. By the way, a lot of people miss this because they did 3 chlorines and 6 oxygens. That's 9. This 3 distributes out to both of these, multiplies them. So it's supposed to be 9 oxygens, not 6. So some of you came up short on your mass here because you forgot that that 3 distributes out to the one that is inside. Convert milliliters into liters by dividing by 1,000 times the molarity. Again, this is the molarity, but I don't like 6.02 M. I don't like that. It doesn't show me units. So I make it into 6.02 moles over 1 liter. Because now I can see liters and liters canceling. Now I can see that I'm left in the unit of moles. After I get to the unit of moles, now I take it times the formula mass. Now again, if you did this right after this, that's fine. I got no problem with that. None whatsoever. Okay? But this has to be the formula mass, and it has to be over 1 mole. And again, we end up with around 809. If you had 810 with a decimal after it, that's fine because you needed 3 sig figs. Questions? For number 3, we're starting out with a mass of calcium chloride. We take it times 1 mole over the formula mass of calcium chloride to get moles. We take the moles times the molarity here, but I flipped it. The reason I flipped it is I want moles and moles to cancel. And sorry, I should have written this out as moles of CaCl2. But I flipped it over because I'm using it as a conversion factor. I'm using it as a way of getting in between volume and grams. So depending on if I am in volume, I use it the way it is set up. If I am in moles, I'm going to flip it over to get to liters. So that is why this is inverted. That is why this is flipped over. That is why this is the reciprocal. I don't give a crap what you want to call it. I flipped it over so that I could use it. And then moles canceled, and I'm left with liters. Now, I thought I asked you to go to milliliters in the problem. I did not. So therefore, you should have ended here, ladies and gentlemen. If you went to milliliters, fine, but that's where I ended the problem, was there. Questions? For those of you who had version B, okay, was still KNO3, just was 250 grams. Same formula mass, different amount of moles. That moles divided by the 0.413 liters gives me, in this case, 6.0 molar KNO3. Okay? By the way, if you write that as moles per liter, it's okay. They mean the same thing. Questions? Different volume that we started with here, different molarity here, ladies and gentlemen, but the same thing. Convert the milliliters into liters. Take it times the molarity. It gives you the moles of aluminum chlorate. Same compound, same formula mass here, ladies and gentlemen. We take the moles of aluminum chlorate times the mass over 1 mole. We will be left with the grams. That, when we round it to 3 sig figs, came out to 317 grams. Questions? Third problem was the same as on the last version. Starting out with grams, getting it into moles. Take the moles times the molarity, inverted, flipped over, however you want to say it. Liter on top, moles on the bottom. That way moles and moles will cancel. I am left with 0.265 liters of solution. Questions? Anyone have any questions at all? All right, ladies and gentlemen. Here's what I will tell you. Your next quiz will not be like this. Your next quiz will be like the problems that we are working on. From here on out, that's what it will be. Okay? So, questions, ladies and gentlemen. All right. Okay, then let's get to work, ladies and gentlemen. All right, get to slide. Sorry, this ain't the right one. There we go. Slide what?
21.
Okay, molarity problem starts on 20. 21 is the first problem, yes. All right. So, we have done problems involving mass. We have done problems involving PV equals nRT. Now we are beginning problems involving molarity, ladies and gentlemen. Determine the mass of silver created when excess copper metal reacts with 195 milliliters of 0.567 molar silver nitrate. Okay, so first step that we are going to have to do, ladies and gentlemen, is we are going to have to write a balanced chemical equation. Determine the mass of silver created. That means silver needs to be after the arrow. When excess copper metal reacts with silver nitrate. Now, silver nitrate, silver is Ag, it is a +1. Nitrate is NO3, it is a -1. So the compound is AgNO3. And because this is setting up to be a single replacement reaction, because otherwise I would not be able to expect you to know what the products are is if it wasn't a single or a double replacement. And the reason I know it's a single replacement is because this is a lone element and a compound. Therefore, we are going to get a lone element and a compound on the product side. I expect you to be able to do that. Now, if you look at your reactivity series, ladies and gentlemen, this one that is the one that says single replacement on this side, okay, this one here, we notice that copper is, where are you? Down near the bottom. But 2 below copper is silver. So we know that copper will replace silver in this reaction. It actually happens. So that means that the silver metal is going to get kicked out and this copper is going to replace this silver. However, when we put copper together with the nitrate, copper will be a +2 charge. Nitrate will be an NO3 charge of a -1. Okay? So our compounds ends up CuNO3 in parentheses 2. Now, if you're sitting there going, how am I supposed to remember that copper is a +2? I literally should have told you that in this problem. I will put a note in here that says something like copper in a compound would act as a +2 because we can't tell by looking at the periodic table. Copper is one of those elements that's in an area where we can't tell its charge. So therefore, I have to give it to you. I did not. I will correct this problem. Okay? I have to tell you in the problem. So on some of your worksheets you've seen where it says copper is a +2 ion in a compound. That's what I have to tell you. Okay? Next thing, we need to balance this chemical equation, ladies and gentlemen. For us to balance this chemical equation, again, if you can do it without doing this, that is absolutely fine. If you need to do this, do this. But I'm writing down all of the things that are involved in it. By the way, because copper is a +2 charge over here, that's why I have the 2 by the NO3. Not because I wanted or didn't want to, but because copper is a +2, I end up having to make it the CuNO3 2. 1 silver, 1 silver, 1 copper, 1 copper, 1 nitrate, 2 nitrates. To balance this off, I have to put a 2 in front of the silver nitrate. That makes 2 of these and 2 of these, which requires me to put a 2 in front of the silver to balance it off. Any questions on balancing chemical equations? Getting this out of my way for my problem. All right. I have 195 milliliters of 5.67 molar silver nitrate, and I want to know how many grams of this I am creating. What mass? That's grams, correct? Okay. So I need to take what I'm given and get it into moles. So I am given 195 milliliters. I'm going to convert that into 0.195 liters. And then I'm going to take it times the molarity, which is 5.67 moles of AgNO3 per 1 liter. Liters and liters will cancel out. Because I am going to grams, ladies and gentlemen, I'm going to keep going and I'm going to do my next step. And I'm sorry, I got ahead of myself there. Before I can do this, I need to use the ratio of silver nitrate to silver. So my ratio always involves what I'm going to on top and what I'm going from on the bottom. So on the bottom goes 2 moles of AgNO3. That is from this right here. On the top, 2 moles of silver. What I'm going to, that comes from right here. Now, I'm out of moles of AgNO3 and I'm into moles of silver. The last part of the problem is to go from moles of silver into grams. So I'm going to do that with one more conversion. I'm going to put 1 mole of silver on the bottom. And on the top, 107.87 grams of silver on the top. Because that is the formula mass of silver, correct? Okay. Moles of silver and moles of silver cancel. I am left with grams of silver. Now again, you don't ever punch this into a calculator, you won't know if you're doing it right or wrong. 0.195 times 5.67 times 2 times 107.87 divided by 2 because it's the only number on the bottom that's not a 1. People ask me all the time, well, Mr. Brand, can I just reduce this to 1 and 1? I don't care how you do your math. Yes, this does reduce to 1 and 1. Reduce it. I don't care. Okay? It doesn't matter. As long as you have this step in there showing me how you get from silver nitrate to silver, if you want to reduce it, that's fine. Phoebe, did you get an answer? Did anybody get an answer so that we can see if we got 2 the same answers? Didn't agree with Josie's, huh?
No, one of us did it wrong.
Well, if you got 2 different answers, that is a good bet. Yes.
Thank you.
Can you give me a number? 1. Thank you, Shenza. You are awesome. Awesome. Now, can you give me the number of grams of silver that your calculator should have gotten? Someone.
119.266.
Anybody else get 119.266? You think that's what you
I
got?
deleted it because then I got scared.
So the good news is you're so confident that you deleted yours because you think it was wrong.
Yeah.
Anybody?
Wait.
119. I can wait all day, but we get less problems done the more I wait.
No, that's not.
Yeah.
Wait.
What'd you get, Shenza?
119.266.
You got that on Achilles' calculator?
Yeah.
Okay.
You don't want to help like this.
119.266. Shenza?
Yeah.
Okay. How many sig figs? 119 grams of silver. Questions, ladies and gentlemen?
How did you get that?
How did I get what?
The answer.
1.195 times 5.67 times 2
Oh, there's a times 2.
times 107.87.
Okay.
So let me guess. You got like 58 point or 59.6. Okay, good. The good news is, if we don't miss this, we're fine. So most of what you did was fine. Okay? Easily explain why you got half. And then we divided it by 2. Again, when I multiply all the numbers on the top that are not ones. All of them. Then I hit divided by. Now, because I only have one number on the bottom, 2, I don't need parentheses or anything. Just divided by 2. The only time you need parentheses is if you have more than one thing on the bottom. And then I hit divided by, parentheses, and multiply all the numbers on the bottom together. Questions? Yes, no, maybe so. All righty. That isn't what I wanted to do. So this is what should be in your notes, okay? Why do I got that way wrong?
That's what I was so confused with.
That's what I'm saying.
Wow. So,
You should have done such a silly thing.
cutting and pasting is killing me, ladies and gentlemen. Here's the good news, though. You guys realize how dumb I am at this stuff, but my second hour doesn't, because I correct it all before I get to them.
We're the guinea pigs.
Are we not your second one?
You're my first hour of this class.
Oh, okay.
So, all right. So we got 119.266 according to Shenza. Of course, we know he's never right, but anyway. All right. Wow. Let's hope my next problem is better, ladies and gentlemen, or we're not going to get through hardly any today. All right. So up here should have been 1, 2 moles aging. On the bottom should have been 2 moles. Told you I was a big fan of cutting and pasting.
Copy and pasting.
Whatever. Cutting, copying, one of those things. There you go. Back there. There we go. All right. I wonder what I messed up on the next one, ladies and gentlemen.
Everything.
Shut up, Eric. Determine the mass of zinc created when excess potassium metal reacts with 356 milliliters of 3.89 molar zinc bromate. Zinc bromate. Bromate, BrO3 on the back of your periodic table, correct?
Yes, sir.
What's its charge?
Good question.
1.
Yeah, it's 1.
Zinc is a +2. That's written on the front side of your periodic table, even though zinc is in that area where we cannot find its charge normally. We told you zinc is always a +2, so that's the formula for zinc bromate. Here's potassium, K, metal alone. Single replacement reaction, ladies and gentlemen. So we end up with zinc metal alone and potassium bromate, if in fact it actually happens. So on the back of our periodic table, we find zinc about 1/3 of the way down at the top. Below it, ladies and gentlemen, is not potassium. Potassium is higher up. which is good because then potassium will replace zinc. Potassium is the second one from the top. So it will actually replace zinc in this reaction. All right. So I'm beginning with 356 milliliters of 3.89 molar zinc bromate. And I want to know how many grams of zinc I end up with. Okay? So we take our milliliters, we convert it into liters. Then what?
Put it into moles.
How?
1 liter on the bottom, and then formula mass.
No.
Oh, I know.
Polarity.
Yeah.
Polarity. So the 3.89 molar over 1 liter. Okay? Liters and liters will cancel. I am left with moles of zinc bromate. Whew. Almost afraid to hit the button, ladies and gentlemen. Yep. Did it again. What step did I forget?
Molar ratio.
Molar ratio. No, not a lot. Let's not say a lot. Let's say one. One step, ladies and gentlemen. But again, it is an important step because we need the ratio to get from one unit to another. So apparently somebody was having a really bad day when he did these. Probably thinking about how much he was going to enjoy teaching this to you guys, that he didn't do it right.
Mr. Arts.
Yes.
He's the alumni. Could be a coffee. I pictures of them will be all over the school.
One to one ratio up above, ladies and gentlemen. Good news. All the rest of my stuff is good except for that one step that I just happened to forget. That's an important step.
Sir.
Again, take what you're given, get it into moles. Molar ratio step. Moles of what you're going to, zinc. Moles of what you're in on the bottom, zinc bromate. Formula mass to get out into grams. Over 1 mole, mole cancel. Moles of zinc bromate cancel. Left with 444.7829 grams of zinc bromate, or 445 grams. Questions? Oh, good. The next ones are limiting reactant, which means, all right, ladies and gentlemen, you've got 20. What? I don't sound that nasally, do I? Get to work. Get to work. Take Hayden's advice. Get to work, ladies and gentlemen. Let's go. I would think all of them. The only part you still cannot do is the percent yield. Other than that, ladies and gentlemen, everything on this worksheet can be done.
Number 7?
Should be able to. That's just what we were doing.
Which one are we doing?
If you want to do the one like we did today, do number 7.
I mean, Thursday.
I was just looking at 7. Wow.
You can just go to my.
Nope. I'm calling it a day. I'm just kidding.
Don't call it a day. You haven't done anything yet.
Exactly. Don't give up. The grind doesn't start until you start. Okay.
I don't really want to go to
Why?
I'm gonna have to do my solo. But I'm gonna do
I think you're not here, Maya.
Well, my timpani solo that they're not fit to practice or we have to practice.
What's wrong with that?
Then I can relay it.
Why are you so anxious? Who's gonna judge you? Screw your boyfriend. He can go play his solo and be able to screw it.
He has to.
He has a solo?
Yeah.
Wow.
He has a class day, so. But it's literally so much.
I really didn't know if it was children.
Well, he has to come finals.
Oh, really? Is that your concert?
He did.
You're in the fine arts.
I am,
concert.
but for visual arts. I'm not in it for music, so I'm not in a concert.
It's visual art.
Just drawings.
It's too